Good morning for those that just joined, and welcome to today's webinar on the tools and data framework to modernise and migrate your data to Azure. This is the fourth in our series for confident decision making with Power BI. We've covered off a range of topics in the series around what Power BI is, how to deploy it in scenarios, how to manage the governance challenges, and where Power BI can play a role with that, as well as Azure Purview. And the last session, we spoke around getting some machine learning and the options you have available to you. In today, we're going to focus a bit more around what else the Azure platform provides will help you with your analytics journey with Power BI. Just some housekeeping to get us started. Please use the Q&A panel inside of Teams. If you have any questions during this session, we'll be able to answer those at the end. If there's a time in the middle, we'll be able to, if appropriate, we'll be able to answer those there as well. This session is being recorded, and a recording may be available for everyone who's registered and attending after the session has been finished and the recording has been published on our website. And with that follow-up email, I'll send you links to the recording and the resources that we mentioned today as well. And we know that modernising your data is a challenge, and so if you'd like to learn more about that, we have an offer at the end to, if you'd like to understand a plan that might suit you in your own journey. My name is Peter Hayden. I'm the Solution Sales Specialist for Data Analytics, and my pleasure to be bringing this to you today. And accompanying me is my colleague, Blair Franklin. Morning, Blair.
Morning, Peter.
So Blair will be taking us through some of the more technical aspects of this. I'll start off with answering the question around why we want to modernise. If you're already using Power BI and it's working now, why we want to consider modernising our data into the cloud if you haven't done so already. And I'll also look at some of those options you have for your databases, taking those to Azure. Blair will then take you through a bit more around Modern Data Platform and how that can improve or give you options for analytics with cloud, and then some of those advanced analytics features as well before we wrap up at the end with that offer in Q&A. So let's get into it and look at saying, why do we think about modernising our data or our analytics platform, and why should we think about shifting to the cloud? I'll start with some information that we did in a survey back in 2019 with our customers, and we asked, what are those challenges you have with moving to a data-driven future? The ones in the red here on the screen were the highest or the biggest challenges that our clients had around skills and availability of bandwidth in the team to do that, the cost to do this, all these analytics activities on premises as well, or not understanding what the ROI looks like in the cloud, as well as quality issues. And security compliance is also very topical for today's discussion as well. And so how does modernising the cloud help us solve that? Now, other questions that outside of the data analytics realm that IT organisations will look at are things like end of data centre contracts, for example, is a trigger event for needing to modernise or shift. Same with end of support. And if you weren't aware, if you're on SQL 2012, that's coming end of life in 2022. I know there are many customers, probably like you, who have even older versions like 2008, which are certainly well and truly out of support. And so modernising can give you some options for how do you take those forward rather than just continue to upgrade on premises as well. Other things like compliance is a key piece, and the application innovation that we get out of modernising to cloud, and you'll see that in some of the platforms Blair will share with you, they're only available in cloud that helps you do that next generation digital transformation. Now, customers choose to migrate for a couple of reasons, and one of those is the optimising that cost. Way too often, organisations would do a major investment every few years into data centre. It's a massive sort of change to keep on pace with that. But with cloud, you only pay for what you use, and you have a lot of the facilities like high availability and disaster recovery built into the platform for you. And then the cloud platform helps manage that going forward, optimising some of your overheads to keep the lights on. Moving to cloud also helps mitigate some of the risk as well. There's a lot of powerful features, particularly security features, that help you to detect or manage security incidents or alert you to any problems in the environment. And some of the modern platforms, break the cycle of having to continually patch and maintain your environments. It happens for you automatically. And of course, that enabling innovation I mentioned just a moment ago, which helps with the challenge of that data-driven organisation. You got scale to be able to then, and services available that you just don't have on premises. So now Data3 is a super Microsoft partner. It is a good question. Why Microsoft for going to cloud when there's other options around? Microsoft has decades of innovation around it, and in particular for data, knows SQL Server very well, of course. And therefore, the migration and transition into cloud is quite seamless. All the tools are designed for going from taking your SQL data environments into cloud and optimized for that. With the Microsoft Cloud, or Azure as the option, you can also take advantage of what's called Azure Hybrid Benefit, which is using your existing investment in software licensing to offset some of those cloud costs. And there's a lot of programming support for helping organizations with POCs, trials, technical support, in some cases, a funded effort through the Azure migration program that could be assistive as well. I'll touch on that in today's session. And then once you think about why modernise, and think about the strategies that you want to employ as well. Now this is this slide has the 4 R's. There are different versions or different numbers of R's that organisations will consider, but these are pretty typical in most situations. The first is that the rehost, which is a lift and shift approach. And this is useful if you need to move quickly, say out of a data center into cloud rather quickly. Use lift and shift, you move those virtual machines into Azure. It's a really good first step that organizations can take to do that. Next option or strategy you have then is the refactoring method. And this is useful because you can modernize your data platform into some of the PaaS services we'll talk about without having to change your application code. So your application can be maintained on a virtual machine or deployed as a web app, but you can optimize your database layer as well. And Someone's vendor applications support that. If you have your own applications, then that's a possibility. For those that have their own development, you can look at re-architecting and rebuilding, which is really then taking advantage of some of the platform as service offerings through other changes to application tier, or a complete rebuild to reimagine what database technologies, for example, you might want to use. So let's look at the database platform and what options you have for modernising your databases in Azure. Now, I imagine that, like most clients that Blair and I talk to, you'll have Microsoft SQL Server in your environment. So I want to touch on, focus a bit on the options for your SQL Server. Now, when you go into cloud, you have 3 options for the Azure SQL portfolio. If you're doing the rehost, you can run SQL Server on a VM, and there's actually some benefits in doing that, where you can plug in some of the with some of the extensions that gives you control over those VMs into the Azure management plane. So it's not just putting and running on a VM, but also start to integrate with some of the smarts that come with the Azure Cloud Platform. That could be a good first way to start. The Azure SQL Managed Instance is another good option, which provides a instance level management of a set of databases. Or if you're looking to have a single database and make the most of that, the Azure SQL Database option is good for you as well. And as I mentioned, Azure is a cloud that knows SQL Server best. It is optimized for running SQL. So a bit more detail on why you might choose those options. And it really depends on how you're using your SQL Server environment right now. You can see the list on the left on some of those choices you might want to make. For example, if you need access to the operating system, or you want to have components deployed on that server you rely on, or some other capabilities listed there, then running SQL Server on a virtual machine might be best choice. A lot of times, though, you could look at that the next stage around, if you just need the instance model, but you want to have things like a SQL agent, or you want to use some capabilities like SSIS, then using that Azure SQL Managed Instance is a really great way to remove the management overhead of the operating system and of the maintenance of SQL Server, and just focus on managing your database and databases as part of your application stack. And then finally, if you are looking to look at the innovation and capabilities available in your database model up to 100 terabytes, ability to scale or pause and restart your workloads, then certainly consider the Azure SQL database as well in that mix. Now, we understand that SQL Server is not only used for just database or transactional applications, but SQL Server gets used also in some cases for data warehousing. And there are other options available to you. And the one that we consider is Azure Synapse, which was released, I think it was last year, as a replacement for the Azure Data Warehouse. And actually now is continuously being innovated and contains many different facets that Blair will take you through today. But it may not be the right fit for you, and then maybe is using one of those Azure SQL Server options might be the right fit for you. So if you have large data workloads, or you need the MPP, massive parallel processing architecture, unified platform for analytics, and some of the features listed there, then that's where Synapse would be really a good option for you. But if that's not where you're at right now, then you can use those other options in the Azure SQL portfolio that I've gone through. Of course, outside of the database, we have other components, those familiar with SQL Server. So things like SQL Server integration services. The new paradigm is now in Azure Data Factory, and that allows you to do the ETL type processes, not only with data sources in the cloud, but also connect back into on-premises data sources as well securely to then help you manage and transform your data. The whole series has been focused on Power BI, which is the replacement from SSRS or SQL Server reporting services. And so if you are using reporting services right now and you've seen what Power BI can do, and we've talked about some of those on-premise options as well, certainly Power BI is the right tool of choice. And if you are using analysis services, there is the Azure Analysis Services option available to you as well. But it is only in tabular mode, and to migrate, you really need to redevelop, redeploy those components, but they can be accelerated through sort of giving you really a lot of investment in those earlier models as well. Now, in terms of what's the benefits of that? What do we get out of that other than there's some nice features? Forrester today did a total economic assessment or total economic impact study across some managed instances and Azure SQL databases, and looked at interviewed some clients, understood what do they get, and overall there was about 238% return on investment over 3 years, above and beyond that transition to migrate those SQL data workloads, and seeing payback within 3 months. What's really I find interesting in this white paper, which a link will be sent to you with the recording notes, is the productivity impact with the IT teams have to manage the hardware and the backups and everything else that goes on with the data center, of course, but the productivity improvement also with in-house DBAs, because all of the things are automated for them to help them be more efficient. And that's even in the hardware costs, keep the data center running is another massive impact that is spelled out in this white paper. Now, when you move to cloud, you also get advantage of all the security features that come with it as well. And it's not saying you can't do this on premises. I know many organizations that have very robust security practices, but the Azure SQL, in fact, all the Azure database options are inherently secure by design. Staying at the bottom of this diagram, things like transparent data encryption, by default that is turned on. Your data is encrypted, which is not always the case when you run this on premises. There's auditing and other monitoring there as well. Access management allows you to be very granular with the permissions you give to your database, not just in the permissions for individual, but utilizing MFA, or be able to control that through VNets and firewalls as well. And then you have things like advanced threat detection, which is all the Microsoft telemetry and smarts, continuously checking for any threats that may be against your environment across the Microsoft cloud, any vulnerabilities on your database as well, and then things like information protection, which if you tend to go purview, session and governance fits into that there as well. And there's compliance out of the box for a number of standards you see on the bottom, like GDPR and PCI. So inside of Azure, it's not only SQL databases, we also have open source databases. So if you're running MySQL, PostgreSQL, MariaDB, certainly there are many options for you to have very similar experiences as a managed instance to run those applications. Azure Cosmos DB is also a relatively, it's not new now, it's a few years of maturity, but is a managed NoSQL database if you are using something like that already. So it includes open source APIs for MongoDB and Cassandra, and it gives you guaranteed response time, single millisecond response times for data writes and reads. It has one of the highest availability figures across any of the database sort of workloads. It's geoscale. We have multi-writes as well as multi-reads across those regions, and it allows for near-time analytics on operational data. Using something like Azure Synapse Link, they use Synapse to query live data out of Cosmos. So how to get started? We actually ran a session earlier this calendar year, the link at the bottom, but I'll send it to you as well. They take you through some of the tools and the assessment processes that you can do hands-on in your environment. But essentially, assessing your environment first, and there's tools like Azure Migrate to understand the current state of your databases, using the Azure Database Migration Service to migrate, and then once you're in Azure, you can optimize and then apply security management tools across that as well. And there's ways we can. There's good guidance on developing a migration plan to support those activities. I'll leave you with some considerations for planning your migration, though, that it's just good to be made aware from our experiences. We talked a lot about modernising your data workloads. Now, intrinsically, a lot of databases are tied to applications. So you need to consider potentially the application modernisation as part of a database modernisation discussion within your organisation. Now, there's a good set of information on our website around going public cloud, and we have the 5-stage pathways to cloud success, which is a program we have for clients already in Azure or new to Azure. And you can see on stage 3 is where we consider then those migration modernisation options as you go towards the other steps of optimization and advanced services. So our processes and programs are designed to help clients like you to be able to modernise, take advantage of cloud services. And finally, there are also programmatic support from Microsoft. The Azure Modernise and Migration program can help you at the part to your planning, readiness, and adoption of those services. And I certainly recommend, when you're considering assistance from partners, look for a partners accredited Azure Expert MSP. Data3 is an Azure Expert MSP. It is the highest level accreditation with Microsoft for helping you understand planning, strategy, the whole migration, as well as the operationalization and governance around cloud services. There's only a handful of Australian-based companies with that, and I do recommend considering that as part of your criteria when looking for assistance to help you modernise. So that was a fair amount of where we've traditional database modernisation. I know Blair now to take us now look at some of the other features available to you in Azure to help you with your analytics journey.
Thanks, Pete. So Peter has taken you around sort of how you can migrate your existing into Azure, and now I'm going to sort of try to cover where Azure really shines and how you can make use of it, especially around your data warehousing needs. So first, we're going to touch on the Modern Data Platform. So Modern Data Platform, you might have also heard it called like the Modern Data Warehouse, or similar sort of terminology that gets floated around. It's made up of 5 components. You've got your data lake, which is your storage for your raw files or tables that are coming in. Data factory, which is your integration, so your movement of data. Synapse, which is your data warehouse. Databricks that can be used for complex transformations or for also preparing data. And Power BI, which is the visualization tool. So data lake can store structured and unstructured data. It can maintain point in time snapshots of data. Data lake is effectively a hierarchical namespace on blob storage, and because it's blob storage, it's cheap. So that's why you can keep multiple copies of the same data, because it's that blob storage and it's that cheap storage. And it also becomes a central location which is accessible for streaming data, machine learning, and data warehousing. Data Factory is an integration tool. So when we talk integration tools, the one most people are familiar with is SSIS. In the modern data platform, it is used to copy data from source systems to a landing zone. So that landing zone will be data lake. It might also be used as an ETL or ELT tool. And it can connect to a large number of sources, both on-prem and in the cloud. And it's a standalone tool on itself, a standalone resource, but it's also actually part of Synapse as well. The link down the bottom gives the full list of the actual connectors that Data Factory can use. Now we move into Databricks. So Databricks is an open source platform on its own. And then within Azure, there's Azure Databricks, which has been refined specifically for Azure. It is based on a Spark engine and is built from the ground up for big data. It's workbook-based transformations, which differs to sort of a SQL store procedure, which is a procedural-based transformation. Think of it as with a procedural-based transformation, it kind of runs start to end. With the workbook-based transformation, we've got segments of code within the workbook, with each one running before moving on to the next, and it can run in a different language. So we might have the first section run in Python to extract some data out of a file and do some processing and put it into a table. Then the next section might run SQL to query that table. Databricks becomes very useful when you need to do complex transformations that need to be broken down, or you might just want to use it as your transformation step within the ELT or ETL process. And then we have Synapse. So Synapse is the data warehouse platform or data warehouse for Azure. It's an MPP, so it's a massively parallel processing. What that kind of means is it actually gets your true multi sort of threading and how it runs, and it's built for big data. Synapse is made up of a few different components. So you have your dedicated SQL pool, which if anyone's familiar with the old SQL DW, this is what it became. You have your serverless SQL pool, which is think of sort of a view or temp table over data lake. You have that Spark pool, which is a subset of Databricks within Synapse, and you have pipelines, which is effectively Data Factory within Synapse. You then also have a few others, which gives you sort of direct links into Cosmos DB, and there's constant new functionality coming out within Synapse. It's Microsoft's sort of flagship product. It's their limitless analytics and continuous innovation. They're always innovating on it, so they're spending a lot of time to get it right and to make it that all-in-one all-in-one place we can do our data warehousing. And then, of course, we have Power BI. So Power BI is our reporting platform or visualization platform. We've touched on Power BI in the last session, so everyone should be across it quite a bit by now. But it's self-service, and it can be embedded in external platforms or internal platforms such as SharePoint, custom websites, phone apps even. Now we can look at how it all ties together. So we have our on-prem sources, we have our cloud-based sources, so cloud databases. We have Data Factory or pipelines within Synapse, pulling the data. The data might be files or it might be tables, landing that into Data Lake. Synapse or Databricks is then going to pull that data from Data Lake, transform it and load it into Synapse. Power BI is then going to visualize that data for the user to be able to see. When we start dealing in the cloud, our data warehouse patterns that we know change a little bit. Everyone will be familiar with ETL. If you've ever created a data warehouse on-prem, you've used the ETL process, your extract, transform, load. When you start getting into cloud data warehouses that typically don't have a data lake, you go ELT. So you're extracting and loading the data into the data warehouse, and then you're doing your transformations. This is so you can keep more of the data in its raw format. When you start bringing data lake into the mix, it now becomes ELTL. So you're extracting and loading the data from its sources, and you're landing into data lake as raw files. It can then be transformed using the Spark pool and loaded into the SQL pool. So Spark pool is Databricks or Databricks within Synapse, and then SQL pool is the SQL data warehouse within Synapse. We then have a slight variation on that, which is EL_t LT. The main difference here is we extract and load our data into data lake as raw files, but then before we actually pull it into Synapse, we're going to do some light transformations within the data lake. So this might be things like cleaning out some of the dirty data which is in the tables. That link that's on this page, if you go to that, it has a lot more detail on the different patterns that can be used for data warehousing. So now we'll cover the modern data platform. We're going to move into the advanced analytics. So this is where we go native. And what I mean by that is we're going to look at some of the resources or options you have within the cloud, which, yes, you can do them on-prem, but it is very hard to implement this on-prem and very easy in the cloud. Cosmos DB was touched on briefly before, but I've gone into a bit more detail now. So Cosmos DB is a NoSQL database, so not only SQL. It has multiple APIs. It's a true multi-region, as in you can have multiple regions all throughout the world, which can read and write. You have different consistency levels. So what that means is the read and write and how it happens in the order that the reads and writes happen is configurable within the database. It's often used with web and mobile applications simply because of the type of format it is. So if we just look at the APIs here briefly, we have the core, which is the SQL. So this is a NoSQL document store with SQL-like querying, and it's document-based. Cassandra and MongoDB are generally used for migration purposes. So Cassandra is a column-oriented schema, while MongoDB is a BSON format. Gremlin is a bit different. Gremlin is a graph database and is based on Apache Tinkerpot. So where we're familiar with sort of columns and rows, Gremlin uses vertices and edges. And then lastly, we have table. So table is a key value pair. We touched on machine learning and how to use it within Power BI in the last session, and now I'll touch on it a bit on how machine learning works within the Azure landscape. So within Azure, we have Machine Learning Studio and Machine Learning Services. Studio has a bit of a next sort of option, a bit more user-friendly. You need to know the basics of machine learning, but you don't have to be a machine learning expert. It also means you don't have the custom sort of logic to be able to build your models. That's where machine learning services comes in. Machine learning services is where our data scientists start to shine. This is where they can come in and they can write custom models and actually start doing some deep learning. Within the machine learning concept itself, we have 4 different sort of ways of doing machine learning. We have supervised, which is where you supply algorithms with labeled training data and define the variables. Unsupervised, where you train on unlabeled data. The algorithm then scans looking for any meaningful connection. We have semi-supervised, which is a mix of supervised and unsupervised. And we have reinforcement. So with reinforcement, we want to teach a machine to complete a multi-step process with clearly defined rules. So we're very much designing that model from the ground up. AI, or artificial intelligence, again, I touched on as last session as part of the Power BI. And within Azure, you have and again, it's called cognitive services. Except within Azure, you have a lot more functionality which you can use. It breaks down into 4 sort of areas: speech, language, vision, and decision. Within speech, you can go speech to text, text to speech, speech recognition, and translation. Within language, we have translation, sentiment analysis, entity recognition, and language understanding. Vision, we have image recognition and face identification. For anyone who's ever used their face to open up their smartphone, that is vision. And under decision, we have anomaly detection, content moderation, and personalized experience. Again, you would have seen decision in action without even realizing it. Anomaly detection runs on most bank databases, fraud detection, and personalized experiences runs on most websites to kind of personalize your experience and advertise the right items to you. Now we move away from the machine learning and the AI space and we start looking at IoT and events. IoT is Internet of Things. In essence, it is any device which can send data. This could be a phone, it could be a Raspberry Pi, it could be your Wi-Fi connected fridge. So we have our big data streams, which is our event data, and we have our IoT devices. We then have our event hubs and our IoT hubs. The event hub captures data as it is sent through. The IoT hub, it also does this, but the difference is with the event hub, it's one way, the IoT hub is dual direction. So the IoT hub can also send instructions back to the IoT device. These instructions might be as simple as update your software, but it might also be something like change the rules. So if we have an IoT device like an edge device, which is connected to Azure, then the IoT hub will be able to say, we want to actually change what has been captured. From those hubs, the data can then be pushed directly into Data Lake, or it can be sent to Stream Analytics. And Stream Analytics can do some sort of real-time analysis on the data that has been captured. That's streaming analytics. We then have that data, and now we're capturing data and we want to be able to report off it. So within Power BI, we have 2 options. We have a streaming data set, we have a streaming data flow. So a streaming data set will use that Azure Stream Analytics as its source, and it will report that data out in real time. Streaming data flow will use the IoT hub, event hub, or blob storage as the source, and it will build that stream within Power BI, and then you can report off it. Just keep in mind, for the streaming data flow, you need Power BI Premium. We then have our Azure Data Share. This was a big one. So if you think on-prem, the only way you really had to share data out was through something like an SFTP, and you're limited to files. With Azure Data Share, you can now share data out to specific users, and you can share and receive data in any format to or from Synapse, SQL database, Blob, data lake storage, or data explorer. So this is tables and files you can share. The user that it has been shared to needs an Azure subscription and a storage location to receive the share. So that's just one thing to keep on track. Now we kind of look at it, and I've talked about the modern data platform. I've talked about some of the advanced analytics. How do we actually tie all this together? The links provided here show some good sort of examples on how this works together. And this diagram ties it all together for us. So within the right in the middle, in the dark gray, you can see all the Synapse and data lake components. So Azure Synapse Analytics pipelines, this is Data Factory. The Spark pools, that's Databricks. The SQL pools as part of Synapse, and the serverless SQL pools as part of Synapse. So we are pulling our data, unstructured, semi-structured, from our relational databases, anywhere we can get our data from, and using our pipelines, we're landing it into our data lake. Up the top, we are pulling from our big data streams, our IoT devices, into our hubs. From there, we are pushing that data into our data lake. We're also pushing off into Stream Analytics. And then off the Stream Analytics, you can see it goes to Power BI for our real-time reporting. We also got some cognitive services and machine learning happening with our Stream Analytics. Now, if we just go back to our data platform, you can see here you've also got your Synapse, which is creating your modern data warehouse off data lake, and it is then also using machine learning and cognitive services to generate some of those models and that AI. We then might be pushing some of this data out to Cosmos DB, which is being used by applications, or we might be using Azure Data Share to be able to share it out. And of course, we are using Power BI to be able to visualize our data. We briefly just look down the bottom now. We've got Purview, which we touched in a previous session, which oversees it all and governs it and ties it together. And then also being part of the Azure platform, we have things like Active Directory, monitoring, key vault, and log analytics as well. So if we just kind of summarize this a bit. Migrating and getting your data into a cloud is just the beginning. Then you want to look at how are you going to optimize your data? And how are you going to build that end-to-end data landscape to really make use of what you have? I'll now hand back to Peter to round us up, and hopefully everyone managed to get something useful out of us.
Yeah, thank you, Blair. As you can see, there was a lot of different things we had to jam pack into today's session. So we've only sort of touched the surface on some of these things, but I do just give you a bit of a taste on what those tools you have available to you in Azure, and some of the pieces about from the frameworks we use, and the architectures and approaches that help you then take that journey to cloud. So this wraps up the series for confident decision making with Power BI. And for those, if you've only joined one or you've joined all four, thank you very much for taking part in this. If you missed any of the content or you'd like to go back to any of those, I think Caitlin's posted a link inside of the chat window. You can watch those on demand, and this session will be available up there also very, very soon. Now, if you do want to know some more information on what's possible with transition to cloud, like some advice, the sessions we've had through our data analytics assessment have been very valuable for a few clients who are looking to understand, just have a chat around, like, where do we go next, or what's what we're thinking, and just help validate a few things. So there's a short form, takes 5 minutes to capture some current information around what you're trying to do in your current environment. We'll set up a time to just have a look through that. We have a scorecard approach to help sort of prioritize what we based on what we see with other clients that might be useful for you, and it might just help provide some ideas or traction. And if you're trying to wrap up for the year as it's approaching December, certainly we can even schedule those into the new year as well. Once you're back from any leave you might be taking and feeling refreshed. So I certainly encourage it. It's a very helpful way just to help progress some of the thinking, maybe some of the thoughts, ideas you've seen in today or session or the series as a whole. The same links on the last page, but there's the contact details for Blair and myself. I don't think there's any questions in the chat. Please, if there is anything else, I'll leave it open for another minute or so. Anything else that you would like to know about, please reach out to us, and we're more than happy to assist you on that journey. There's a lot of complexity, as you saw, and not only complexity, but potential opportunity for your organisation to take some of the demands that you might be seeing in your organisation to help better the overall analytics capabilities that you're looking to achieve. So with that, thank you very much for attending, and look forward to a new feature series. And if there's anything we haven't touched on in the series, also there'll be certainly please reach out, and love some ideas for what we could use in the future. Thank you, everyone. Have a great day.